Hi and welcome to my channel. So today I'm going to take a look at this Hewlett-Packard 1660C logic analyzer. You've probably seen this if you've watched my other videos. I use this quite a bit when I'm working on, retro computing stuff. Logic analyzer is great to have if you're into digital electronics. There's a bunch of older ones on the market like these Hewlett-Packards, and they go for pretty cheap because they're not really useful for modern electronics. They're just too slow to trace the signals on a modern computer. However, something like this 1660C, it's got plenty of bandwidth to look at the signals on, my old Radio Shack computers. So, it's a useful tool to use around the lab here, and I'm going to pull it apart and show you what it's all about. First thing I'm going to do, I'll just boot the thing up. It's got a nice satisfying sound when it boots up. You can hear there's obviously a hard drive in there. You probably can't hear on the video here, but I can hear it. And then it does its self-test. And it goes into the GUI. The GUI itself's pretty late 90s. You can select with these arrow buttons what you're modifying. The operating system on this thing, I think, is VxWorks. It's an embedded OS. And basically there's a bunch of menus. I'm not going to get into the operation of this unit, but it's basically a full function logic analyzer, and it works quite well. It certainly works really well for what I use it for. It's kind of neat. It's got a keyboard right over here. It has a hex keypad here. Got a nice little floppy disk for saving some of your configurations, and on the back we can take a look at it. It's got a few different connectors here. We've got our HPIB, so this is a GPIB interface for connecting up your instruments. RS-232, so apparently you can log into the console on the VxWorks, and that's quite interesting. I've never done that. Keyboard and mouse, so you can connect a old style PS2 keyboard and PS2 mouse to this. It's got a parallel printer port, and then it's got these pod connectors here. So there's actually 4 pod connectors, which allows you up to 8 pods. And the pods, well, they look like this. So they've got basically a connector on the end of it. Comes off, and then you connect this up to the device under test. And there's a few options for connectors on these things. So enough of that, let's take this thing apart. Okay, and the unit free from its case. There's a really nice aluminum casting. The whole bottom is cast aluminum, which is awesome. Looks great. Let's take a look inside, see what we got. This whole area on this side where the floppy drive is, the keyboard, it's all like pretty heavy duty aluminum. Then we've got our ribbon cable here, which is double sticky taped down. and that's going to a hard drive. So there's a hard drive right there. So it is a computer of some sort. And then it goes into, there's a box on the side here. So you can kind of see there's this aluminum shielded case. And I'm gonna guess that's actually a power supply. I think that's a power supply right there. So let's take a look and say, yeah, it says warning shock hazard, and then we've got our 120 volts coming in, and it goes into this unit. So that's the power supply right there. I mean, the construction on this is pretty awesome. Certainly compared to a PC of the era, this would be well overbuilt. Like, I mean, this whole back is cast. The slots here, you can see they're for airflow, but they're reminiscent of slots from like a PC. But it's all cast. It's not stamped metal. And then, let's take a closer look inside here, see what we can see. Underneath the CRT, we've got a really standard Crt Driver Board. It looks like we've got some controls here, low brightness, sub brightness, and there's a main brightness connector going out to the back of the unit, which allows you to adjust what they've labeled as intensity there at the back. And then we've got some more adjustments. We've got V-lin, which is probably V-linearity, V-size, V-hold, and H-hold. That's pretty standard stuff. It's actually nice that they've got all of these adjustments on the Crt Driver Board, because I pulled apart a few Tektronix oscilloscopes, and they don't have a lot of adjustments on them. I think there's only like 4 adjustments that you can do on them, and it's a bit frustrating. Now, this board here potentially has really high voltages on it. There's a big capacitor there, relatively big, but this flyback is, a high voltage source going into the CRT. I'm going to be very careful about touching things around here. And I don't like how this isn't shielded, but, I'm not an HP engineer, so I don't know why that decision was made. This is just a standard ribbon cable. Yeah, the board's clean. I mean, it's nothing too exciting, but it's, obviously it's HP, it's going to be top of the line. Okay, let's take a look inside here in the actual unit itself. This is pretty much a boring teardown, and I'll tell you why. Because it looks like there's these here main chips. There's 4 of them, probably 1 for each pair of pods, and they're basically completely covered in a heatsink. So these are likely an ASIC for HP. And then if we look over here, they have on the front end HP branded parts. That's all your acquisition side right in here going to the pods. So those are all HP branded. Those part numbers, there's not going to be any lookups for them, so no real way to tell what I'm dealing with here. Just looking at the acquisition board here, and I noticed that each of the custom acquisition chips we've got has their own voltage regulator. So there's LM337s for each one, it appears, and there's actually even more. There's 5 here, there's another one here, all nicely heat sinked. So it's quite an interesting setup they've got there. Not sure why they have all of those regulators on the board, but obviously they wanted to make sure there was nice clean power to those, and they've done it. Okay, I'm going to try and pull out this hard drive assembly and the power supply, and I figure they probably just slide out. So let's just see how this all connects together. We got 2 screws here for the hard drive, and there's these knobs, sort of switchy things here, which seem to hold everything together. Let's see if there's any way to turn those. These are all double-sided sticky taped on, which is, well, kind of a lazy way to build things as far as I'm concerned, but you know, hey, whatever. I got those. It hasn't fallen apart in 20 years or more. Oh, okay, so this is actually the floppy drive up front here. And, you know, there's a possibility that I can just pop that out. You know, there's sometimes you pull things apart and you just don't know if you want to go any further. I'm starting to feel like that already on this one. Okay. The assembly is moving and it is coming out. Now I've got pretty good experience pulling things apart. My experience putting them back together again, sometimes a little less than I'd hoped for. Let's try to pull this out. There we go. Okay, so we've got the assembly out. Great. And let's take a look at this drive here. What do we got? We've got a Hewlett-Packard branded, part number on there. 3.5 series, 3.5 inch IDE drive, it looks like. And it doesn't really say how big it is. Who knows? It's from 1998, 04/27/98. It says how much power it takes. Doesn't say how big it is, but it ain't that big. I'm gonna guess 500 megs, something like that. There you go. Some interesting oxidation on the bottom of this thing here. Floppy drive assembly. Now I gotta pull these down, and I might just sort of rest these out of the way. In fact, I might really want to pull these out of the connector, but I'll pull them out of the hard drive there, and floppy's out. So now the question is do I want to keep pulling things apart? Well, you know what? It looks like these things just come out. That's really weird. It's like a handy pointing stick that's just kind of tucked away, holding things together. We got one of those, and there's another one on this side. This one is a little tighter. Let's see. It should come out. This is the weirdest. I've never seen these in anything before. Like a little plastic pointy stick to hold the unit together. Okay. Here inside there's this ribbon cable here, and it's quite interesting in that the conductors are separated. They're really separated a lot, which makes me suspect it might be a high voltage source as opposed to a lower voltage source. But it's going to the motherboard, so that doesn't make sense to me either. I would think that if it was a high voltage source, it would go to the CRT driver, and even then, you don't really need a high voltage source in your CRT driver as long as you've got a high voltage generator on that board. I'm not 100% sure I want to pull that cable out, but let's start pulling and hoping and all that sort of good stuff. This power supply is stuck in there good. Take a look at this. At some point, the power supply actually fell out. See this slot here? There's the slot. The power supply is bent. It's supposed to be in that slot. So actually, maybe this device took a bit of a hard fall at some point in its life, because it is like totally stuck in there. And I just don't know how much I want to pull that out. In fact, I know how much I want to pull it out. I don't want to pull it out. Question is, am I gonna? I'm going to use a little force on this and see if I can sort of bend the frame a little bit and make this thing fit. There we go. Got it. Okay. And then now it's going to just slide out. Right, see, that's pretty nice. And I'm going to pull this ribbon cable at the back. And I'm going to pull the high voltage cables out the back as well here. And there we go. This is the power supply unit. So here we have the power supply unit. We've got voltage outs there, and we've got our voltage input, and we've got an adjustment there, which I'm not sure what that would adjust. Maybe the trim, it's a voltage trimmer or something. I mean, this is a pretty skookum power supply. It weighs good 3-4 pounds. Not lightweight at all. It's got a TÜV sticker on here. I think this might be made in Germany. It's that, I mean, TÜV is a German certification. I'm not sure where this unit is made, but I wouldn't be surprised if it was made in Germany. So there you have it. And then our compliance stickers, CSA, all that good stuff. Well, I'm not sure I'm going to pull this apart, but maybe I will. Put it aside for now. And here we have the main logic board. So this was the cable from the power supply, and it looks like this board is connecting through this connector here down with some ribbon cable to the acquisition board. So this bottom board is the acquisition board. And if we take a look at what we've got here, we've got a obviously a RAM, set of RAM chips here. Not sure how big they are. They are, can't even really read them. 4400 CJ. Anyways, it's a memory card for sure. And then we've got a bunch of 7 series logic here. A little bit of it. We have an Altera Max FPGA, looks like. And then we've got a Motorola 68020, which is pretty awesome. Since I'm a Motorola fanboy, that's pretty cool to stumble upon that. And then there's your real-time clock here, a little beeper, a Daptec, that's going to be a drive controller, probably floppy drive controller, I'm going to say. An HP branded chip with no part number. And then there's this Sonic T thing, which is, I'm going to look up that part. Let's see what it is. Okay, through the magic of Google, I figured out what that Sonic T part is. That is a network controller, which is kind of odd because this doesn't actually have a network port, but there's a good chance that that is actually controlling the GPIB or HPIB port on the back. So there you go, network controller. And yeah, that's basically it. So essentially this is a small embedded computer with a 68020, decent little processor, an FPGA doing some interesting stuff. I'm not sure what it would be doing, but it's there. And yeah, network controller and, you know, support parts in order to you know, handle the functions needed by the computer. It looks like this is a ROM chip right here with our software on it, our BIOS software. But yeah, that's about it. So essentially what we've got is a small PC, 68020 PC, with an embedded monitor, embedded keyboard, nice little power supply, nice monitor driver on the side here, and acquisition board to pull in the digital data. So it looks like the CPU is a 25 megahertz 68020, which brings up the question, you know, could a person who is dedicated enough install OS 9 on this machine and run it as a OS 9 computer. I mean, it's got a keyboard interface, it's got a mouse interface, it's got a CRT. Maybe it's possible. It might be an interesting project for someone who wants a 68,000 based OS 9 computer for $100 or so. So the FPGA that we have on this board is an Altera Max 7128EL. This is a 2500 gate unit, which is pretty pathetic in 2018, but in 1998 it was probably pretty nice. It's got 100 inputs max on it, and I gotta be honest with you, I have no idea what it's doing on this board, but they probably used it. Well, I'm not even gonna guess why they have that on there and what it does, but yeah, it's a pretty standard Altera chip from the late 90s. I don't really want to pull this power supply apart, but trust me, this is a high-end power supply. It's really nice, and proof is right there. It has got nice Rubicon capacitors, and as expected, 1998, they're not bulged at all. Those are still working fine. And then in there's a transformer I can kind of see. Not too exciting, but you know, this is a standard switching power supply, albeit a high quality one from HP. Well, there you have it. You've seen the insides of a 1660C logic analyzer from Hewlett-Packard. Not the most exciting device in the world. It's really just a computer with an acquisition board, but yeah, it's interesting how they constructed it. Anyways, I hope you enjoyed that video, and if you like what I'm doing, please subscribe. Love the subscribers, need the subscribers. And yeah, thanks for watching.